Nitrogen gas is the major constituent of the air 78%. It is an inactive gas in the comparison with oxygen, which is another main constituent of the air. The way nitrogen gas in the atmosphere is converted into animal and plant protein is shown in the nitrogen cycle. Here, atmosphere nitrogen is first converted into nitrates. These are formed either directly by leguminous plants or via oxides of nitrogen or ammonia. These nitrates are then absorbed through the root of the plants and are converted into plant protein, which is eaten by animal and turned into animal protein. Plants play an essential role in converting nitrates into protein. These swelling on the root of the leguminous plants such as bean and peas are capable of taking in nitrogen from the air and converting it into nitrates. This is called nitrogen fixing. Animals are incapable of converting the vast quantities of nitrogen in the air into protein and rely entirely on plants for this. In a world of expanding human population, this places pressure on crop production for both animal and human consumption. To make such crop production more efficient, intensive farming techniques are employed. These rely heavily on the use of fertilizers to replace nitrates which are removed from the soil by growing crops. The production of fertilizer is the job of the chemist. A lightning flash is a high electrical discharge. This surge of energy combines oxygen and nitrogen atoms together to form oxides of nitrogen. These oxides dissolve in rainwater to form valuable nitrates. Ammonia is the most fundamental compound of nitrogen. It is produced industrially by the Haber process. The raw materials for the process are hydrogen and nitrogen. Hydrogen is produced industrially by cracking oil and nitrogen from liquefaction of the air. The two gases are combined directly in a ratio of 3:1 and are passed over an iron catalyst at 450 degrees Celsius and 200 atmospheres. This reaction is reversible with the forward reaction producing ammonia and the backward reaction decomposing ammonia back into hydrogen and nitrogen gases. The catalyst in the Haber process is the transition metal iron with promoters of iron oxide. This speeds up both the forward and the backward reactions, so the point of equilibrium between the two reactions is reached more quickly. When the ammonia has been produced, it is liquefied out by the reducing the temperature to minus 34 degrees Celsius. And the unconverted nitrogen and hydrogen gases, about 70% of the initial gases, are recycled to avoid wastage. The boiling point of ammonia is minus 33 degrees Celsius, of nitrogen is minus 196 degrees Celsius, and of hydrogen is minus 253 degrees Celsius. Ammonia is the only common alkaline gas, so it can be identified with moist red litmus paper turning blue. However, a more specific chemical test is to hold close to the suspected ammonia a glass rod dipped into some concentrated hydrochloric acid. This will give off fumes of hydrogen chloride gas, which in the presence of ammonia form a dense white smoke of ammonium chloride. In the same way, mixing a gas jar of hydrogen chloride and ammonia gas produces the same dense white smoke. The smoke again is the fine particled solid called ammonium chloride.